Hello! Today I'm a little frustrated because I have recorded a cool video for you using OBS and the output completely sucks. I don't know why. I need to upgrade somehow my equipment here. As you can see here, this is a dead cat. This is a Zoom H4n Pro Black, and I think at least the audio quality is acceptable now. So today I want to show you something on my progress on the cat tip side. So yeah, actually I was searching for something else, no? Spark SQL syntax tree, and then I saw this O'Reilly book, and then actually I just found out that the author is me. So if nobody is telling me that I'm great, I'm telling it to myself. That sometimes helps. Yeah, so the stuff I'm actually doing at the moment is also pretty interesting. So just 1 minute here. This is Cloudpack for Data Watson Studio pipelines, which is a front end for Kubeflow. And what I'm doing is the claimed components. You might know what the claimed components are if you are following my channel. I will give you a little update in a second on those. You can create easily Kubeflow pipeline components and other containers. Or basically, you can transform a Jupyter notebook into a container, Docker container, and that you can then run on Kubernetes, Docker, Airflow, Kubeflow, Kubernetes jobs, command line, you name it, okay? And that's pretty cool. Now, so you have your code, data science, code, Python only, and you don't know, you don't need to know much about all the YAMLs and deployment descriptors and you name it, no? That's pretty cool. Yeah, so the thing I'm doing at the moment in my current project is just I need to finish this data engine. This is a query engine service to be callable from a Kubeflow pipeline in this tool. So this is the code, no? That's just plain Python, and then the claimed magic transforms this into a container image and also creates the Kubeflow pipeline YAML. But you see here it's dash manual, so I needed to tweak it a little. But then it magically appears here, and you can set the parameters here. Yeah. And so on. Okay, so that's just an example how easy you can create anything from a Jupyter notebook. But today we wanna dive into CatTip a little more. I have let's say something a little bigger than Hello World running. And I was inspired by just running this particular experiment because of a question on Stack Overflow. So there someone had a problem with the TensorFlow training job. So this error here, too much memory needed, and the accepted answer is basically just reduce the batch size. And I'm arguing that the batch size is a hyperparameter and might influence your overall performance. And I thought it's a nice idea to just double check if that is true. So if we now go to CatTip here, by the way, I had to, even it's showing localhost, I had to move it to a cloud Kubernetes environment. So you might remember I've shown you how to install CatTip on OpenShift and also locally on Kubernetes in Docker, but it's just not strong enough my laptop to actually train it. And the IBM Cloud Free tier for Kubernetes also is not strong enough, so I'm running here I think a 4 GB 16 core or something node on Kubernetes service in the IBM Cloud. But anyway, it runs in all the Kubernetes environments you can imagine. And we had a little issue with security. So the IBM security team actually told us we are not allowed anymore to expose public HTTP endpoints let's say very easily. No, we have to do a lot of additional security things on top of it. So that's not a problem because in Kubernetes you can basically just issue this command here. It's here kubectl port forward, and then you tell the target, so the service and the service name. So that's the Ketip user interface, and then here the namespace, and you map then your local port 8080 to the remote port 80 of the Ketip UI service. Okay, that's pretty cool. That's anyway something you have seen in the kind example. Another thing I just wanted to show you is, that's also something I found out, is a pretty cool command. So you have here, no, that's not the command I wanted to show you. So this one is, you can set a default namespace. I wasn't aware of that. So you say kubectl config set context current namespace kubeflow, and once you have done that, you say get pod, for example. Then you see all the pods in the kubeflow namespace. So this nasty -n, so get pod kubeflow. So you don't have to provide the kubeflow namespace anymore. Okay, so anyway, so let's go back to the actual code which is running before we do anything else. So the code which is running is, as you might guess, a Jupyter notebook, and this notebook is just encapsulating the TensorFlow training, so it exposes the necessary interface as environment variables, for example batch size, no, and also it sets defaults, and then later on it does the training. And one thing I have done, that's just a little modification from state of the art, let's say, is I have added a callback handler for the metrics, and this metrics logger here, extending from Keras callback, is on the on training and callback, just writing the validation accuracy and training accuracy to standard out, and we will see later why this is important. Okay, so that's just a notebook. If you run it top down, it does everything automatically, and claimed transforms this into a container image, and this container image you can then, for example, just push to Kubernetes as a batch job. Now, so you see here, that's the reference to the container image, and you can set all the parameters you like via environment variables. And you might guess where the data is coming from. In this case, the data is coming from a mount to a PVC, a persistent volume claim. And let me just introduce that to you rapidly, because you might not be aware what all this is about. So there are storage classes in Kubernetes for different types of storage, and so the standard default one is something you can use. It should be always there. Worst case, it's just on the file system of your nodes. And that way you can create a so-called persistent volume. That's a meter information mapping, basically, or providing storage to the Kubernetes system, and it's cross namespace. Okay, so and then on top of that, you can create persistent volume claims, actually pulling from those persistent volumes. Those are specific to namespaces, and the mapping between PVC and PV, so persistent volume claim and persistent volume, is done automatically. So Kubernetes decides which persistent volume it should use for creating the PVC, which is sometimes a little black magic. So that's one thing. Then where does the image data come from? So this is another job which uses another container image, and the magic here is, as you have guessed maybe already, also coming from a Jupyter notebook. So this is a Jupyter notebook pulling data from a Git repository. In this case here, this is, where's the Git repository? Here, that's the Git repository. And in my opinion, it's okay to mix and match shell commands and Python commands. That's why we have notebooks, no? And it extracts the data, transforms it a little, and then it puts it to the data tier. And the data tier is basically mounted via PVC and PV in Kubernetes. No? So if you run this once, then the data is already there, and you can run this as a Kubernetes job if you like. You can also run it in Airflow or Kubeflow or from the command line, doesn't matter. Anyway, it just pulls the data, and also it supports skipping. No? If it's already there, it doesn't get executed twice. That means you could, for example, pull this code into an init container to your training container, and that's running every time. But in case the data is already there, it's just skipping. No, that's the idea. And obviously, then you can have this training job here, and this is the ordinary Kubernetes job specification, but I can modify it a little. So basically just remove the metadata to turn it into a Katib job specification. And the other thing you need to do is you have to have these placeholders here. That's the way how Katib injects the hyperparameters into the training containers. Okay, so but let's actually have a look. So I just told you I wanted to show that batch size is a hyperparameter which needs to be tuned. So if we go back here to Katib, so that's basically accessing the remote Katib installation on Kubernetes via the proxy. And if you now go to the experiment, you see here those are the trials. So 3 are running, 2 have already succeeded. And let's move me here. So you see here it's 2 and 4 as batch size, and you see here already that the batch size influences the validation accuracy. It's very low. I need to tweak the model a little, and maybe it's not enough epochs, but I mean that's why we have hyperparameter tuning. No, I can now search through this space and get a good accuracy. Yeah, okay, so as a last thing, I mean, I will come back to you if this is finished. Each experiment runs around 9 hours, and only 3 are running in parallel. So I think it's 12 in total. So maybe today evening I can give you an update, or tomorrow. But I want to show you how to actually create such an experiment. Okay, so just from the scratch, this is the notebook. So any container is sufficient, but it's just here an easy way to create such a training container. Create a notebook, use the claimed compiler, and create a container image, and push the container image. That's all done here in the notebook itself. Then it's available in the image registry, and after that you can test it easily, no, by creating a Kubernetes job. But once this is already running properly, you can create a Katib job, experiment. So let's dive into this. So obviously, if I would like to run this, I need to rename it to experiment 2 because the random experiment name is already taken. Then I just tell how many trials in parallel I want to run, and also how many examples or points in the hyperparameter space I want to try out. And this has to be lower than the max trials. So there's a validation missing, okay? So you need to set this number not higher than the available points in your hyperparameter space. I just noticed that because I'm here, let's go to the hyperparameters. Yeah, I'm jumping a little, but anyway, so I want to optimize over batch size, no? So batch size, and so I choose discrete values, so 1 and 2 and so on, no? And 4 up to 1024 I have chosen, I guess. So those are now 4. And since this is the only dimension, if you now say here 12, it will complain because there are only 4 possible trials. And if that's larger, then the UI doesn't get it, no? Anyway, just for your information. Okay, then here the validation accuracy is the one I want to optimize on. And you see here the metric name, validation accuracy. That is basically the one you need to output here in the log, no? Validation accuracy. So that string equals, that's how Katib pulls it. Okay. Then search algorithm, in this case I've just done a simple grid search. Obviously now, since the whole setup is working, we can now try out all the other cool algorithms. So early stopping none, hyperparameters already defined, metrics collector. So that's the interesting thing. Standard out is simple. No, I just need to, as again, tell you again here, log the validation accuracy to standard out. That's all what's needed. But you can also have different ways of pulling your metrics. Anyway, so and then the interesting thing is the trial template. So you can pre-store them in the config map, but I'm just using a plain YAML here, and now this YAML comes into place. So this is the YAML I've created. So that's the basically a Kubernetes job, no, where we omit the metadata, and then we can just paste it here. And you see here that batch size is already recognized, no, because this pattern here is automatically searched for, okay? And now what you need to do is you need to map the pattern here. I would suggest some auto mapping anyway, but you need to map those, no? So you have to say batch size here from the YAML is equals the batch size you have defined here in the hyperparameters. Yeah, that's it. You say create, and then you will end up with such an experiment. And depending on your configuration and number of parallel trials, you will see that reflected. And each trial is basically a pod. So if we now go to the command line, and then we will see that we have 3 running pods for the trials, those, and then there is 4. And there should be, here, sorry, no. So this is the driver pod. So that's the cat pod which drives the experiment. And then you have 1 and 2 and 3 running the trial, and this container status unknown means basically terminated. I already found that out. See, oh. So, okay. So you see here it's, okay, so I have to specify the training container. That's mine, no? So you see here, name here, training container. That's the one I've created. And then there is a sidecar, no, the metrics logger and collector. So this pod consists of 2 containers, the training container and the sidecar for the metrics collection. And now it says terminated, no? Yeah. And that's actually, those terminated ones are those here, the succeeded. Okay. Yeah, okay, that's it for now. I hope this recording went well. Otherwise, I'm just too frustrated and will do it another time. Yeah, stay tuned. I will show you how this turns out, actually, this whole thing. And obviously then we can just dive into other hyperparameter tuning algorithms and actually see how they perform. Okay, have fun, all the best. Thank you, bye.